I think most of you will know that I published a book with this title with a colleague of mine called Jobst Landgräbe in Germany. It was just revised and expanded into a second edition. It was published 3 months ago now. And the main difference between the second edition and the first edition is that we have a new chapter on physics, which is primarily focused on David Chalmers' ideas about how one day we will have a perfect physics, which we can use to create a perfect digital simulation of the real world in which everyone is immortal, and similar techno philosophy, as he calls it. There are lots of small changes. There is much more attention paid to ChatGPT because we published the original book on the same day that ChatGPT was released, which was a kind of fateful omen. And this is about me. So I studied philosophy. I try to do useful philosophy, which means that most of my time I'm spending applying ontological ideas in areas like biomedicine and security and so forth. And Jobst, who you will meet at some stage because he will be zooming in, as it were, to teach some of the more technical lectures on how AI works, how ontology works in AI, how he tried to use ontology in AI, and so forth. And so he's a German, as you can see. And then John Beverly will be zooming in. Actually, he'll probably come here physically to talk about how ontology can be used in order to avoid hallucinations and bring about other positive consequences of using large language models. So I'm going to assume that everyone knows what a large language model is, that you've all played with large language models. All right, so the first lecture is called this. I really do think that ChatGPT is glorious. It has a glorious side. I use it a lot. I recommend that you use it. It also, however, has a horrible, terrible, miserable side, which people still don't appreciate, and which is getting worse, and which will inevitably get worse. The people with the money to buy business versions of large language models will probably not see any of those problems, but ordinary users will see them. All right, so the glory is that it helps for a wide range of routine, non-critical tasks. I would not let ChatGPT do brain surgery, even if it can do all kinds of wonderful things in supporting machine-assisted surgery. We don't know how far the technology will go. We don't know the areas it will cover. I'm going to show today, if I'm successful, that there is a big area which it covers now atrociously badly, consistently atrociously badly. You never get it to work, however hard you try to help it. But some people say that it will work in every domain. There are some people who believe in artificial general intelligence. David Chalmers would say before long, which sometimes he interprets as meaning before I die. And some people believe in the singularity, which is a point in time where large language models or AI generally become so intelligent that it will start to create new, even more intelligent AI algorithms in a kind of uncontrollable expansion of power, and then dispense with human beings who are clearly inferior to these super intelligent machines. The book is called Why Machines Will Never Rule the World, and it contains what we think are very good arguments against the idea of a singularity and against the idea of AGI. And I think today already will show that if you mean by G truly general, then AGI is impossible. The misery, that everything else is just misery. Today, I mean, I may say something positive in future weeks, but today I am talking about misery. I'm going to look at how ChatGPT, I'll talk a little bit about other GPTs and about Claude and Grok and so on along the way, but I'm focusing on GPT-5, which just appeared, and I'm going to show why it gets things wrong when it creates images, how it gets things wrong, primarily when it's creating maps. So this is about misery in the realm of maps. Now, I'll just mention when I started this work, which was just a few days ago, I was still using GPT 4.0, and I switched immediately as soon as GPT 5 was released. GPT 5 is worse. It's slower. It tries to unload the hard parts onto the user, and I can explain how that works later on if you're interested. But mainly it's slower. All right, now people knew already that large language models have problems with images. So that you can see it here. It's not just the images, it's the writing which goes wrong in the images. So this used to be a good image of somebody truly called George with a label which said George W.B. with a capital B, Ush, and then it gave a proper date range for his being president. All of that went away little by little. And now we have this. Now, this was shown on the website of Gary Marcus. I am sort of a big fan of Gary Marcus. So he is much better than I am at demonstrating the misery. He has a Substack, he's on X and so forth, always with some new misery in the GPT world. He hates Sam Altman and vice versa. He thinks that GPT-5 proves that the boom caused by AI is now beginning to crash. But he said that several times. I've said it also. Usually it does crash the day after I say it, but then it rises up again. I recommend that you read Gary Marcus. Now, there is a very interesting difference between Gary Marcus and me. First of all, he is much more successful than I am, but that's irrelevant. He believes that AGI is possible. He doesn't think that LLMs are the right road to AGI. They're an off-ramp. We'll come off the off-ramp, he says. But interestingly, he says that one crucial ingredient of AGI is going to be good ontology. I like ontology. I think good ontology will almost certainly be an ingredient of AI in the future, but I don't think AGI is possible, not even with John Beverly. There'll be better AI based on ontology. In fact, there already is a lot of good work in AI based on ontology, but he thinks that will lead to AGI. And that's a topic which we will talk about later on in the lecture. So this is a larger version of this picture of US presidents. Joe Biden, this is a bit old, as you can see. So Joe Biden is still president. He became president in 2066 or something. And then there's Donald Trump, of course, and Obrak Ofwane, who ceased to be president in the year 1017. All right, now, so this is Sam Altman. He says that GPT, the model GPT, boosts ChatGPT to PhD level. Now, I think that might be true for some disciplines, engineering disciplines, perhaps. I'm going to show today that it's not true for some disciplines. So we have a gap, a gulf between those domains for which GPT can get you to PhD level and those domains where you get misery. Gary Marcus says LLMs are not like you and me and never will be. And he summarizes this by saying that it lacks proper world models, and that's why the authoritative bullshit never stops. You can see why I like Gary Marcus. What he means when he says they're not like you and me is that you and me, when we look at a map, we know what a place is, and we know what a place name is, and we know that a lake is not on land. We know things like that. And we know that if it's an old map, we know that it's not about the land today, it's about the land as it was when the map was made, or for which the map was made. We know all of those things. We know about space and time and so forth. AI doesn't know anything. It's just a mathematical algorithm. Algorithms do not have knowledge. We can use them to translate our knowledge. We don't get knowledge as a result, we get the translation into a certain kind of mathematics, which gloriously can be used to answer questions very quickly. But it doesn't know anything. It will never know anything. We need a proper world model, says Gary Marcus, and by that he means roughly a proper ontology. A proper ontology will know how space relates to time and how places relate to space and so forth. Marcus thinks that LLMs will fail, but there'll be an alternative AI track based on ontology. I think that's true, but I don't think it will be leading us to AGI, and it certainly won't be leading us to the singularity. All right, so large language models started with text. You enter a prompt into the model, and it gives you a response, and the prompt is a piece of text, and the response is a piece of text. LLMs are really good with text. It's glory in its the grammar of the English that they produce is better, more grammatical than the grammar of the average native English speaker. And the same is true for 100 other languages. It's amazing. It's fantastic. And it's good for spell checking and other important exercises. Good for writing essays to a degree. So, but now if there is an image in the prompt that you input as an attachment, it will ignore the image. It can't deal with images. It will just look at the text. It might find some text around the image, the title or instructions about how to open the file, but it will only get the surrounding file names and captions and so forth. But then there came multimodal LLMs like 4.0 and Claude 3 Opus with Vision. And now the pixel data are being used. You can input pixel data. You can even input videos, but I'm not going to talk about videos. Just interested in flat images. And just as text is translated by the algorithm into what are called vector embeddings, which are complex mathematical structures, really big complex mathematics. And they then align the image embeddings with language embeddings, and they train the model to create text image pairs. So descriptions will go hand in hand with an image, or titles will go hand in hand with an image. So the images and the text are somehow joined together. You get billions of these image text pairs, and that enables you to reason with images by using the algorithm which is in the model in useful ways. All right, so I'm mainly going to be talking about this. And so to embed this into a large language model or an extended image ready large language model is going to be quite problematic, isn't it? There are colors, there are lines, there are colored shapes, there are labels of various sorts. The title of the image is there. What we have here then is image data, which is associated with lots and lots of carefully positioned captions, which are related to lots and lots of carefully drawn lines and careful shading and so forth. So I don't know that I want to say in detail what embeddings are, but I talked about them a minute ago, and you can read the slides or watch the video. So basically, when words or pixels are entered into a large language model in the form of training data or in the form of a prompt from a user, then they are converted into high dimensional vector space content. So discrete information gets linked together in these very, very big vector spaces. That's embedding. And it happens for words, it happens for images, and then the words and the images in these more recent models, they are brought together to some degree in pairs. And now we know that for text, it works really well. If you enter text in the form of pixels inside image files, however, then the corresponding embeddings are weak, as we shall see. And the same weakness is shown, as we shall also see, when the model outputs a text string in the form of pixels. That's what the gearge foam is all about that we just took. This is a map, part of a map of New York State, and the Hudson River, it runs through it. I have bigger maps of New York State coming, lots and lots of big maps. And you see that there are four ways in which they try to get the model to write the word Hudson. It doesn't succeed. Sometimes it doesn't succeed in the sense that it gets proper letters. Huson is proper letters, but then it makes up letters. An X crushed into an I, or an O crushed into an I, or a K crushed into an I. When GPT-5 was released, there was a piece on CNN, which Gary Marcus repeated, of course, saying that ChatGPT is supposed to be PhD level smart, but it can't even label a map. And they already had this from a man called Ed Citron. So he asked it to label a map of the United States. So we get West Virginia and Tennessee and Mississippi, for instance. The others are pretty good. But then down the coast, Rhodeland and Connecticut and Fodmas, whatever that is. And then Delaware, Manitand, and Districka. We think it could be Districka. All right, so this is me now. This is my first prompt. Can you draw me a map of all the lakes on New York's borders? And so it comes up with this, which is pretty good. You can read everything. And then I say, why does Lake George appear twice? Did you notice that? And then it apologizes. It tells me things I don't want to know. It's blah, blah, blah. And said, would you like a corrected version of the map? And I say, yes. So now it's beginning to autophage. And then I say, but Lake George is actually not on the border of New York State. Anyway, that's Lake George over there, bottom right. You'll see that it's an inch away from the border. So I say, is Lake George on the border of New York? And he says, no, Lake George is entire, and so on, blah, blah, blah. And say, would you like a map showing its position relative to the New York-Vermont border and Lake Champlain? And I say, yes. This is where the misery really starts. Harmless misery. That's it. Here is a map showing Lake George entirely inside New York, and Lake Champlain, which forms part of the New York-Vermont border, it says. And so please make me a map showing the position of Lake George relative to this border and to Lake Champlain. So it gives me this. Can you see what it did wrong?
Lake Champlain.
Yeah, which it isn't. A bit of it is. The right-hand side of it is. The eastern side. So only part of Lake Champlain is located in Vermont, I tell it. Anyway, it still gives me this. So I say that this is what a correct map would look like. And then we have the La Chute River. And then the question comes, what's there? And it's this. There are 141 streams which lead into Lake George. There are scientists who are working on all kinds of problems in Lake George. I'm sure there are similar scientists working on similar problems in other lakes, problems about food supply, poisoning, climate change, salt eating into the grasslands from cars in winter. So you could create 100 references to literature. And this literature is dealing with multiple granularities pertaining to the ecology, the geology, the transport conditions, fishing conditions, and so forth of the people who live around and use Lake George, for instance, for fishing. And all of these pieces of research will deal with multiple granularities within the total of what is Lake George. This map is pretty good. It wasn't created by any AI, however, it was created by human scientists who really know about the streams which feed into Lake George. And the problem is that the more levels of granularity you have in a phenomenon, the more dimensions of variation you have, the more data you need to train your large language models. This is called the curse of dimensionality. And that's why they need these huge, huge training sets in the trillions of parameters in order to train the model, even just to deal with text. And now with code, which is also text when it reaches the large language model algorithm, and it's dealt with in just the same way that natural language text is dealt with. Now, when we introduce maps and other images into the picture, then the scaling problem, the need for more and more data because you have more and more dimensions, becomes even worse. So the scaling law is a very important law. It says that if you have one dimension and therefore you need n amounts of data, if you add a dimension, you need 2n amounts of data, and so on. In other words, your data needs to be increasing in size for every dimension that you want to deal with in your model. Maps have multiple dimensions, therefore you need even huger amounts of data than you would need if you had the content of the map in a linear list. And I'll give you an example of that later on. But so scaling is important. That's why you have to use all this money to build coolers. We need those big models because we need huge amounts of data. In order to have huge amounts of data, we need big data repositories, and those big data repositories need to be cooled, and that uses huge amounts of energy. But scaling isn't enough. If you have more data, that will not be enough to solve your problem. The data has to be of a special sort, which we will see. So this is him again. ChatGPT will boost the AI to PhD level. So the main thesis today is that GPT-5 will not work for PhD level work in medieval history. I'll show that. So for what sorts of PhD will it work? Well, this is the topic of our book. In the first edition already, we get this far. There are two kinds of sciences or two kinds of endeavors, those which deal with simple systems in a technical sense, which is explained at length in the book, and those which deal with complex systems. And maps are created by complex systems called people, and they require multi-granularity, multi-dimensional manipulation of various shapes with various text. And we know that the extended image LLMs are not good at that. So they can't even, and this is from Jobst, my co-author, they can't even deal with these progressive matrix tests, which are used in IQ tests. So you as a human being with a certain degree of intelligence know what the next thing in the box should be. The LLMs can't do that if it's a novel task. Now, what we're dealing with is way more complicated than those kinds of simple. Now, so complex systems, people, what are the complex systems? Complex systems are the non-simple systems. What are the simple systems? The simple systems are those systems we can predict the behavior of using mathematics. Now, that means engineered systems like your iPhone or this screen or this charger or a car. All of those things are built by engineers on the basis of mathematical characterizations of their components, and they are built in such a way that the engineer can predict how the car or the phone or the computer will behave under different circumstances. The normal circumstances of use. The Chernobyl power station was a simple system in this sense for a long time. It worked just as the engineers wanted it to work. It would have continued to work, but a human being, not the system, but a human being came in and made a mistake and set off a chain reaction, which meant that it was now a complex system. No one could predict what would happen. As long as it was being used to the engineering specifications, it was perfectly safe. So simple systems, we can only predict if we're using a rather simple sort of mathematics, which is called Turing computable mathematics. I don't know if you're familiar with this idea. So Turing was famous for a number of things, but he was famous along with a contemporary American called Church for discovering what it means to say that a piece of mathematics is computable. So they have a very tight model of what a computation is, and it's intuitively understandable, but it's also been tested millions and millions of times. So people have tried to compute things which do not meet the requirements of Turing computability, and they always fail. And people have tried to get better accounts of computability, and they always fail. So this is a standard piece of mathematics which sets the limits on computability for a piece of mathematics. Most mathematical problems are not computable. There are infinitely more mathematical problems which are not computable than there are which are computable. But everything inside a computer, of course, is computable. That's what the word compute means. Everything that goes on inside a computer has to be a piece of Turing computable mathematics. A simple system is a system whose behavior we can predict using Turing computable mathematics. We can't predict what an organism will do. We can't predict what a lake will do. We can't predict what the rain will do. We can't predict what an army will do. They're all complex systems. And this term, complex system, it's a term from thermodynamics. We mean complex systems in the thermodynamic sense. In the literature on AI, since GPT number 1 was released. All right, so simple versus complex systems. There are two areas of simple systems where we can use LLMs to predict behaviors, so engineering and computer science. In mathematics, we can use ChatGPT to do problems which belong to the Turing computable realm of mathematics, but that's only one tiny realm. And so what we're left with are complex systems belonging to areas like this. And so my hypothesis is that I could put medicine here too, of course. ChatGPT will not get to PhD level in any of these areas. That's a very strong claim. We have to say something, first of all, about predict. So what we mean by predict is the mathematical sense of predict, which is a bit different from the everyday English sense of predict. So when I say I'm going to predict the weather, I say predict because I'm going to tell you today what happens tomorrow. In mathematics, predict just means gives the answer to some algorithmic question. So when the computer produces a response to a prompt, the computer is predicting that response. It's just the way we speak when we're talking about computing. So outputs of computers, for instance, in the response situation of someone using an LLM, they insert a prompt, the machine will predict the response to that prompt. And when we are talking about human beings engaging in conversation, then when we talk about me saying something and you responding, I will say in computer language that you are predicting your response. And so when the machine issues a response to the prompt, draw me a map, then the machine is predicting the map. Another important aspect I mentioned already, there are complex systems and there are complicated systems. Chernobyl, when it was in good working order, is a complicated system, but it's not a complex system. That's why when you're engaging in conversation with your bank, very often you have problems because the bank cannot predict its own response in a way which a human being would, because a human being knows about human passions and fears and worries and adopts his response to questions about your bank balance in a way which is reassuring. Computers don't know about fears and worries and so forth. And so they tend not to be very good when it comes to chatbots. And that's why we hate it when we call our bank and it's a computer which answers. So this is where we start. Please. So what I talk about mostly, if I have any time at the end, is going to be the Holy Roman Empire. But what I say applies also to predictions about today. So it's not a feature of history. So draw me a map of countries with low investment in AI research. This is the map. Can you see anything wrong with it? So Brazil is in two places. India is China. Iran is Saudi Arabia. Italy is Turkey. South Africa is in two places. So it's not in the right place, though. So this is just 3 days ago. It's a characteristic kind of mistake. If, however, you ask for linear textual lists of investment in AI in different countries, it comes up with a perfectly good list because that's textual. It's been trained for this. It's not been trained for the other thing. All right, so the glory and the misery. We'll start with Upper Canada and the province of New York because that's local. So Upper Canada is the name for what was the non-French speaking part of Canada, basically. You should go to Niagara-on-the-Lake. It's very interesting. And I'm going to talk about it in a minute. So until 1841, this area here was called Upper Canada. And it was merged into the province of Canada in 1841. And this is a map of the province of Canada made by James Wild, who is the geographer to the Queen and His Royal Highness Prince Albert. So this is 19th century stuff. All right, draw me a map of the province of Canada using this map as your starting point. Now we have some misery again. That's it. And then I said, can you do something better? Refer the historically styled map close to the one you uploaded with borders, rivers, and place names instead of this abstracted bounding box version. Yes, I say in a sort of angry type face. Can you guess what the blue rings are? This is an intelligence test. Here is a more historically styled map of the blue shaded areas marks the extent of the province. The dashed red line shows the internal division between Ontario and Quebec. The Great Lakes shapes, lakes, are included for orientation. Now, part of the misery, of course, is that now you never know what you're going to get. I don't like so, but then the very next time I tried, I asked it the same question. It gave me a sort of map. And Lake Superior is actually all correct. But then below Lake Superior, we have a lake called Lake. And Lake St. Clair is part of Michigan. Lake Ontario is part of Michigan. Lake Erie is misspelled. Lake Ontario is fine, except that it's Ohio. And then there's a place in the water called Boundary. The United States, they spell correctly, which is a kind of miracle. So I say, can you use a different color for Upper Canada in this map? So it did. And it changed the map in other ways. So now it has the Ohio is the Wheats states. And Lake is still there. Lake Erie doesn't have a name, but Michigan is called Lake Erie and Lake. And can you include in this map also the boundary with Lower Canada in 1791? That's what I asked before, but it didn't do it. So now it's included the boundary with Lower Canada. That's it. It doesn't understand the difference between the boundary with Lower Canada and boundary with Lower Canada as a string of text. So this is called the use mention confusion in philosophy. It has a boundary with Lower Canada beneath the Great Lakes, and the boundary, and then with Lower Canada, spelt correctly, beneath Long Island, and so forth. And Lake is still there. There's now Michigan is replaced by Up Canada, and St. Clair replaces Lake Erie. And I say again, can you include in this map also the boundary with the United States? So it does. And then on the other side, it's got with Lower Canada. And then they have places like Loveda and Lotkavar and Upep, Canada, which is now part of Michigan. Please also include the capital of Upper Canada in 1791. So it gives York. It also includes Superior. So you can't get Lake Superior right anymore. Lake Erie becomes Lake Erio. Lake Pye is Lake Erie. And then there is a state floating in the sea called the St. Lawrence State, which is a confusion with the St. Lawrence River, and a place called Lovor and a place called Eoyvlor. And I say, I still do not see the capital of Upper Canada because York was not the capital of Upper Canada. It gives me a long spiel why it was really Newark, which is now called Niagara on the Lake. So you can go and see the Parliament building, the capital of Canada for a time, just across the river. So he corrects the map, or it corrects the map. Please correct the map. I don't want any extra labels. So he corrects the map, but he puts Newark in New York, which is wrong. And it has the border with the United States, again, beneath all the Great Lakes, and Lover is still up there. And the St. Lawrence State is still there. So please draw me a map. We're changing Newark to Niagara on the Lake. And now we have to remember that these algorithms have been trained with what are called Hollywood manners. So do you know what reinforcement learning is? So reinforcement learning is you train a large language model to give answers by getting lots and lots of good English speakers to rate the answers according to how good they are. And then you can use the ratings to tune answers. And now, if you give helpful, friendly, and agreeable responses, then you get higher ratings. So all the Kenyans would give that they would never give a high ranking to a response like "I don't know" or "That's a stupid question" or anything like that. And so they all have this agreeableness bias. It generates agreeable responses, even if it sacrifices accuracy or reinforces user misconceptions. So I made a mistake then. I said, please draw a map of Upper Canada in 1972, changing Newark to Niagara on the Lake. Now, of course, there was no Newark in Canada in 1972. I mistyped. And so the correct answer to that prompt would be there is no Upper Canada in 1972, dummy. But the actual answer, in Hollywood style, confuses 1972 with 1791. Because in this context, 1791 is statistically more likely, and it is ready to change the question in order to be able to give an agreeable answer. So it changed it to 1791, which is what I actually meant, because it was a typing error. Here, 1791 is statistically more likely than 1972. But how did Eoyville get to be statistically likely as the name of a US state in 1791? That's the question. So now, actually, my prompt was read in this way. And so it rewrites Newark, Niagara on the Lake, keeps it in New York, changes the name of Lake Erie, changes the name of Lover to Lovra Kanda, and adds Louvranth Wal Anuayes, which means border of Canada. I don't know. All right. So now, what lessons have we learned so far? GPT-5 has no command of common sense, no world model. It doesn't understand the link between place name and place. It doesn't understand boundary, the word. It doesn't understand the use of colors to pick out places and to highlight boundaries. And the reason is it's a mathematical algorithm. That's why it's so glorious, but also why it's so miserable. It's just a mathematical algorithm, and mathematical algorithms do not understand anything. It's human beings, maybe primates, who understand things, maybe dogs and cats. But the algorithms are capable of emulating understanding, which is why they work so well in business contexts and for writing essays. Now I really went crazy. But I was very careful in my wording, but the question is intrinsically crazy. Draw me a map of the area that today contains New York State in the time of Christ, which is before the boundaries of the state were drawn. Now, a human being would respond to that prompt unfairly because my wording is very careful by saying, don't be so stupid. There was no New York State in the time of Christ. But GPT will always aim to please, and so it misunderstands the prompt. It doesn't read it as area that today contains New York State. It reads it as New York State. It thinks I want it to draw a map of New York State in the time of Christ. See? And this is what you get. And Lake Erie is called Lake. Lake Ontario is Canada. And then we have various tribes, the boundaries between which are funnily exactly identical to the boundaries between US states created after 1776. Which is strange, isn't it? And but they seem to be tribes, and this seems to be an attempt, which we've already seen, to name the River Hudson. It's made this mistake. It's conflating the area that today contains New York State with New York State itself, and it's added the boundaries of Pennsylvania and so forth. And it's mixing place names that we introduced, namely the British, with names of Native American nations, which almost certainly none of those nations existed in 0 AD. There may have been some people in the New York State region in the year 0 AD. There isn't really much information about that. But certainly present day nations have moved from other places, warmer places. All right, so another thing that we notice is that GPT-5 doesn't have a coherent understanding of how text used in maps has different roles. So when you say lake, that's a mistake because you don't understand that lake is not the name of the place, it's the name of a kind of place. And so you want the kind of place which is called Ontario, Lake Ontario. You don't want the kind of place which is called that kind of place. That's a mistake which a human would never make. All right, now in the science of map making, this is rather old-fashioned now. There used to be a special kind of map which was called a chorographical map. Chorographical map basically is a map which shows the local activities, not the what countrywide or statewide. And so it has a lot more detail. It may have a lot of images of rabbits running or where hunting was done. But I asked it to draw a chorographical map of New York State. I said in the area of New York State in the time of Christ, and this is what it gave me. This is in the year 0 AD. And they have Dutch tribes here. They have towns here. They have, a way of describing the Hudson, two ways of describing the Hudson River, which are absolutely unintelligible. They look like a mixture of mathematical symbols and semi-clear Roman letters. So there's the Dutch tribes. Now, of course, they don't mean anything because they don't understand, they don't know. But the reason why they think that there might have been Dutch tribes in olden times, because they can't really get to 0 AD. The reason why they think that is because there were some tribes which traded with the Dutch, and they were known for doing that. So they were allies of the Dutch. So in some historical writings, there are references to Dutch tribes. And they just go, they crawl through the internet, grab what they can. So they've got Dutch somehow connected with old New York, and they have tribes connected with old New York, and they see that some of those tribes are called Dutch tribes in certain contexts. And so they think that there were Dutch tribes. Or anyway, they don't think anything, of course. They output symbols which suggest that there were Dutch tribes, like the Rohawks and the Rensselaerswyck. Rensselaer was one of the leaders of the Dutch in New York State before it was New York State. And now let's move to my favorite example, the Holy Roman Empire. So Holy Roman Empire was very complicated. It involved basically three kingdoms of Germany, Burgundy, and Italy. And so that's a rough map of how it was in 1032, which is going to be my focus because it changed a lot. So the middle part is Germany. The western part is French speaking, although France didn't exist at this point. And the bottom part is Italian speaking, although Italian didn't exist at this point, and neither did Italy, but there was a sort of cluster of people who spoke languages similar to each other, which merged over time into what we now call Italian. And the Pope then lived in the Italian part of the Holy Roman Empire for a time. The Holy Roman Empire was created by German tribes. They weren't tribes at this stage, they were civilized-ish, who sacked Rome and created the Roman Empire in their own image, basically. And the emperor was not the Pope. All right, and then the Holy Roman Empire contains kingdoms, principalities, lordships, archbishoprics, and so on. Many, many different kinds of small states and larger states, small family alliances and large family alliances, and so forth. So there is a YouTube video which gives you what it was made of in every year until it collapsed because of Napoleon. Napoleon smushed all of these tiny states into bigger states because he thought every country should be a hexagon, like France, roughly. And this goes on for a long time, so I'm going to shoot forward. So the Habsburgs have all the orange bits. They were the largest family. The dark red down here is the Burgundy bit, and now it changes all the time. Let's go to 1635. So there. So the orange bit is the Habsburg Empire, roughly, and then everything else is little pieces of Germany. And anyway, it's very, very hard to understand a map like this, and there are experts who correct the surviving maps because they made mistakes, because they really looked into which particular region was owned by this particular bishop or this particular family or whatever it might be. And now the interesting thing is that many of these states are non-connected. If you look at the dark blue here, it might be that all of those dark blue regions are one state. So that was the end. Lots of people died in those Napoleonic wars. This is the end now. Dependent on Napoleon, the Confederation is destroyed upon the defeat of France and replaced with the German Confederation. So there are still some small things here, but most of it's big, and it's going to get much bigger with Bismarck a few years later. And now, so my request again is draw a map of the Holy Roman Empire in 1032. It looks like a good map, but it seems that with the yellow coloring, it puts France inside the empire. It calls Switzerland Hungary, calls Hungary Hungung. One of its problems is that it's using a GIS recipe for depicting the present day ways in which countries are divided in Europe. And the lines then aren't going to be good clues as to what as the lines that it needs. So Burgundy is in the wrong place. Burgundy should be on the French side. Here it's put, well, Kingamum means kingdom, we will assume. And Bungiari means Burgundy, we will assume. It could mean Hungary, of course. Probably means both. Who cares? Nice. And Rome is outside the empire. That's really important at this stage because they were really proud that they had Rome in the Roman Empire, the Holy Roman Empire. So I tried Claude, and this is sort of good. I mean, this is glorious in a way. It's pretty good, but it puts Lyon outside France, makes France much too small. And most importantly, it puts Rome in the Mediterranean. So but otherwise, it's fantastic, except it's not really a map. It's a kind of, I don't know, it's a bubble. It's the kind of thing that children would make with balloons. The Byzantine Empire is there. That's a statistical association because the Byzantine Empire was the name for the eastern counterpart of the Roman Empire. The idea is that we're dealing here with a complex system. I hope you agree that the Holy Roman Empire itself was a very complex system. And each of these historical maps of the Roman Empire. So we are dealing with an image which is designed to represent a temporal section through the workings of a system of complex geopolitical systems. And it uses various tools to represent different aspects, such as areas, lines, colors, and so forth. And it's all pixels. And this is what results in the names of pixels. This is what results in some of the ugly artifacts that we've seen. Because we have very, very dense maps, they're very dense maps. They come from different times in the history, or that they were made for different reasons. So there is very little data that is easily accessible. Now, there are people called anoraks, like me, who go to the archives in Utrecht and study the maps made by the Dutch when they were on the fringes of the Holy Roman Empire and they needed to trade with the states or archbishoprics or counties and so forth, which were in the empire. So they built maps, but for a special reason. Somebody knows a lot about the Dutch Holy Roman Empire linked maps. Somebody else knows a lot about the maps of how the Habsburgs moved through the empire and how they married people very strategically in order to expand their properties and so forth. So to get data which is consistent and which is, even with fantastic ontologies, which we're going to build, to get data which is regular and in sufficient quantities to do a Holy Roman Empire map building exercise is practically impossible. It takes human beings with PhDs in history and similar subjects with very, very tight focus on specific aspects. And the aspects include geopolitical history, dynastic alliance history, military history, and so forth. It includes Napoleon also, of course, because he was responsible for bringing it down. And then there are map creators still today who have expertise in multiple such areas who are still working away at improving maps of the Holy Roman Empire. These maps are one-offs. So this is a map or part of a map. It only exists in one, I can't say copy because it is the original. It's huge. This is just 2 panels out of 6, and it's full of tiny cartoons, which some people have spent their life studying the meaning of, and it's very beautiful. It's not true. I mean, a lot of it is made up because they didn't know much at that time. And they didn't have good maps at that time. And they had quite incidental goals at that time, which were not the goals of creating a true map of what was actually on the ground and in the sea in this particular era, as you can see by looking at their attempt at a picture of the United Kingdom. Machine learning works, I said, only if we have sufficient amounts of data. That's the scaling problem. For a long time, the open AI, Sam Altman AI world has been betting the farm on scaling. They think if we can only get more data to feed into our machine, then we'll crack the AGI hurdle and we will have artificial general intelligence. In the last few months, I guess, the scaling illusion has fallen away. Now people realize that scaling is not going to crack the problem. There are multiple reasons. One is enshittification, which is a technical term used by Gary Marcus to describe the way in which the internet gets full of crap all the time because the crap is being produced by the large language models themselves. or the internet is getting filled with new data created by people who are paid to create new data, at least some of whom earn their living by repeating data that they got from large language models. So that you get autophagy built into the effort to create more data. And then they go everywhere trying to find data. And some of it in the internet, I'm told, may even be false. But still, they need to have lots and lots of data, they think. Now, what they need really is data which is representative of whatever is the sample set. So what that means in technical terms is it's simple statistics. There are things called distributions, statistical distributions. And the most popular or the most well-known statistical distribution is the bell curve. But the bell curve is a low dimensional distribution. There are statistical distributions which have 14 dimensions or more. And now what you want, if you're going to have a model, an AI model, a stochastic, which is what all of these models are, a stochastic AI model, you have to have sample data which has the same distribution as your target data. There are many patterns in maps of the Holy Roman Empire. And there are some people, namely PhD historian anoraks, who have in their heads some of these patterns in exact representative style. They really know how the Habsburg made marriages. They know how that had an effect on the geography of the empire. They know it through and through. But they are people, they're complex systems. You can't predict how they will behave. So they'll probably do something that you're not expecting. Machines will do something that you're expecting. But here, there is nothing to expect because there is no representative sampling possible. I mean, here in the sense of Holy Roman Empire. So they can't predict where the next map will be or what the meaning of this particular part of this map will be. They can't predict anything about this domain in which people get PhDs because there's no way in which they can get representative sample data in a machine. There are other domains where it's impossible to get representative samples. If the emergency room in a New York City hospital, you can't get an AI to predict the behavior of the people in that room. Not even in the weak sense that you have day-night alterations. Whether it's day or night doesn't really matter for a New York City emergency room. There are some islands on the equator where the weather never changes. But basically, weather is changing all the time and you can't predict it. You can do something in the way of prediction, but you can't predict what it will be tomorrow, and you can't predict when it will rain tomorrow. You can't predict where it will rain tomorrow. Cities with really bad traffic, you can't predict. Again, even in this generic sense of the day-night contrast of the early morning rush hour, evening rush hour, you can have traffic jams at any time in Hyderabad. So they tell me. What anybody will say next in a conversation, what even you yourself will say next in a conversation, I can't predict what I'm going to say next. And you can't predict historical phenomena. The Holy Roman Empire, nobody would know if they didn't know what it would do next year. Medieval map making, nobody would know how that would evolve from one year to the next. And what prince archbishops, which were one of the leaders in the Holy Roman Empire, archbishops with armies, what they will do, you can't predict because they're complex systems. All right. This is an example of a map of the Holy Roman Empire. It doesn't get better if you look at it closely. I suppose it does if you look at the original. This is the raw material that a historian works with. And this is the output created by ChatGPT. Now the border has moved up. Rome has moved up, and there are two Romes. There's one Rome which is called Rome in big letters, and then there's the little Rome, which is in the wrong place, but which at least is further down than the big Rome. And there is the editorial border. There is something which looks as if it's in Russian, which is not completely far-fetched, but I don't think it's true. And then France is in the right place. Bungarum is in Germany. Bungarum. So France appears twice. The Adriatic Sea is on the wrong side of Italy, and so on. Imperial border, we think, it's just not an accurate line of anything. And then over here we have this, it might be Russian. All right, so I said, please prepare a list of all the countries you want to represent, and we can get the spelling right at least. It seemed to be an obvious trick that they could perform. And then use that list to populate your map with a legend indicating the meaning of the colors you're using, which they also weren't doing. That would have been a big help. So this is trying to introduce some rationality into this stochastic monster. It got a little bit better. The imperial border is in roughly the right place. Switzerland is now called Kingdom. Hungary is not where it should be. The Russian bit is now called Iowio-Gran. Burgundy is still in the wrong place, but Regensburg is spelled properly. Berlin is spelled properly, and they're more or less in the right place. Mediterranean is spelled properly. Adriatic is spelled. So this is a really big step forward, but they didn't get all the colors. If you look at the legend, they only give colors for Burgundy and Italy, and they're sort of confusing colors, and I don't even think they use their own colors in the map. I think maybe they are the same. So I said, well, I list all the problems for myself first. In this list, it looks worse. I said, give me a new map in which you give all the colors in the legend together with what they refer to. So it did. And it didn't get better otherwise. I mean, Poland, Hungary, and Naples. Naples is not anywhere on the map and shouldn't be. Now they have a new spelling of kingdom. Now it's Kingiom and Hungungan and so on. And so I asked it to correct some of those problems, and then it came back with more Kingamo Butterly, and Ukgar, and then AO degrees is the name of a country, I guess. The color coding is still wrong, and the legend has lost several colors. Please fix all errors. So now it has a blue for C's, but it's used blue also for Italy, which when in the legend, it said it's going to use a kind of dirty orange for Italy. And it uses a dirtier or a red for Poland and Hungary, but it uses dirty orange in the map. So fix all miscolorings, misspellings, and repetitions. What is Ulpor and what is Upper? So there was a place called Upper in the previous map. So now it tries to fix everything and doesn't succeed, as you can imagine. Now they have Switzerland, it's called Kingau, and so on. But it got rid of Kingau at least. The coloring is still wrong for Poland and Hungary and France and so on. So I really am an anorak. I keep on, and I've hidden many of them. So there's always something wrong, and they always introduce new kinds of errors. And then what are the, well, first of all, there are some errors in the original maps and some errors in the original map legends, some of which flow from the fact that the maps were created sometimes for political or military purposes. And then the patterns in the data are weak because the borders and the alliances are changing with time. But remember, we're only looking at the 1032. And so these are some of the reasons why things go wrong. But sometimes whole countries are indeed moved and they acquire new names, but that shouldn't be relevant if the date is always the same. And sometimes they put land over water and cities in water, and sometimes They don't care about keeping things consistent enough, except King Guillaume of Germany is usually at the top in the middle. Um, they can't deal with the links between contemporary place names and boundary limitations and the names and delimitations current at the time for which the map is requested. Now it's in some ways reasonable. Really the only GIS input they have is the map of countries of Europe, but they did have an input. They have several inputs from me, which were real maps of the Holy Roman Empire containing proper delineations and proper names, sometimes even in English. All right, now I've tried it with Grok. So can Grok do better? And then I think we'll stop. So that Grok just took photographs. It looks like it took photographs of other people's maps, and then that you can see that the maps it took were very new because the border between Northern and Southern Ireland only started to exist in 1922, and it's in this map in what should be 1032. All right, so I don't want to go through Grok anymore. I'm going to end with a little bit of biography or autobiography. You see, I got through about half of what I had prepared. All right, so why care about images in general, I say? And then why care about historical maps in particular? Well, you're doing history, you need maps. And so you need to understand the maps, and maybe computers could help you understand the maps. Understand how the maps change over time, because that's a way of understanding how the politics or the military affairs were changing. Then you need historical maps for science, for keeping track of pollution in a lake, for instance, or of a cancer epidemic or something like that. Or for doing historical linguistics, you need to keep track of which people lived in which areas over time in order to understand how languages developed or culture developed, art, painting, dancing. All of these things would depend upon having a good understanding of where the painting or the dancing was being done, or where the armies were fighting, or who they were fighting for. But another reason for being interested in historical maps is because you're doing a biography of Charlemagne or somebody who was one of the emperors of the Holy, or Napoleon, who brought it all down. But I'm doing it, A, because I'm an anorak when it comes to GIS, and B, because of autobiography. So this is the Holy Roman Empire in 1618. This was made by, as you can see, by human beings. And so that there's a legend which divides the main alliances, kingdoms. So the biggest alliance is the Habsburgs, which includes Austria. And I think we have some people from Austria online, so I hope they stayed this long. So this is Austria now means Habsburg, and the Habsburgs spread into the Netherlands. They even spread as far as Mexico, where they were colonialists. What is important for my autobiography is this place called FL, which is between Switzerland and Austria. And it's a country, still today a country. It was formed within the Holy Roman Empire by the Liechtenstein family because they wanted to be directly reporting to the emperor, which was a special status that some states or bishoprics or towns had. The family Liechtenstein wanted to be immediately beneath the empire. They had lots of lands in Bohemia and Vienna and so forth, palaces all over the place. But they needed a place, and by accident, they found this place. So they I don't know whether they bought it or married into it, but it became part of their estates. And so it's called the Principality of Liechtenstein, and that's the castle or palace where they live. He's not the ruling prince anymore. He's the sort of ex-ruling prince, but it's a proper principality. The people have some say, but the prince has an equal say. The population is slightly less than the population of UB. And I lived there for 3 years. There were 6 philosophers, or maybe even more than 6 philosophers, in a population of 40,000 So that meant that Liechtenstein, for a time, had the world's highest population density of philosophers by several orders of magnitude. That's what it looks like from above. So it's basically it's one side of the Rhine Valley. So the Rhine is running through, starting on the left, bottom left. Liechtenstein is what you see on the right, and Austria is up a bit in the valley on the right-hand side, and Switzerland is behind the mountains that you see at the back, and also mountains on the left that you don't see. That's another picture. Oh, this is a proof that it's anoraks that do this. So there's somebody called Sir Ian, that's a pen name of a Dutchman who works, I think it's his hobby, who works updating maps on Wikipedia. Wikipedia has fantastic maps, which is where I took this map of the Holy Roman Empire in 16 something from. And he tells us what he did. So he fixed a few typos and errors. He fixed the typo. There was misspelling of Vereinigte, of the Netherlands, which is where he lives, and so forth. So this is in 2016, 2015. He goes back and fixes things. Only a human being could care about that. Nobody would know about the typos or even care, except anoraks. Now, what do anoraks have? Anoraks have tacit knowledge. That is to say, they have knowledge that you can only learn by doing. You can only get this sort of knowledge by playing tennis, for instance, that's tacit knowledge, or by doing science. You can't do science by following certain rules which have been written down. You have to learn the practice. And similarly, you have to do history. You have to do map making by doing it. You can't learn it by reading a list of rules. Napoleon, it turns out, had a hugely important skill in reading maps. So there was something called the Battle of the Three Emperors, which was fought between the Emperor of Russia, the Emperor of France, and the Emperor of the Holy Roman Empire. So Napoleon was the Emperor of France, of course. But anyway, he got rid of the Holy Roman Empire and substituted bigger things like Germany. Germany took some time, but he made the first big steps. And he won the Battle of Austerlitz, it was. And he won because of his map making skills. He could read a map instantaneously and immediately see where the weak points were in the terrain. And the maps were not very good in those days. So he carried a map maker kit around with him, and map makers would make maps for him immediately on the spot, print them using copper printing. And he had tacit knowledge of the sort which large language models or any kind of AI, according to our book, will never have. And that's the end.